You can see the leakage through this stainless steel butt welded globe valve at site at fully closed condition. If the inside fluid is ordinary fluid like air or water, then we can ignore this type of leakage. But if the fluid is hazardous like steam or ammonia, then with this much of leakage, it will not be possible to do any maintenance work at downstream of the valve. That's why valve leakage class has come into picture. From engineering point of view, we define all valves as zero leakage or bubble tight shut-off valve. But in reality, it is just a term. Almost all valve leak by some amount during testing. Thus, valve leakage class has come into picture. As per ANSI FCI 70-2, that means Fluid Control Institute of America, there are 6 leakage classes for valve. First, leakage class 1 means valve's construction is same as leakage class 2, 3 and 4, but valve testing is not required. It is dust tight only. Then leakage class 2 means allowable sheet leakage rate is 0.5% of rated flow through the valve when tested using air or water at 45 to 60 psi gauge. Then leakage class 3 means allowable sheet leakage rate is 0.1% of rated flow through the valve when tested using air or water at 45 to 60 psi gauge. That rated flow means flow through the valve at full open condition. Then leakage class 4 means allowable sheet leakage rate is 0.01% of rated flow through the valve when tested using air or water at 45 to 60 psi gauge. Then leakage class 5 means allowable sheet leakage rate is 0.0005 milliliter of water per minute per inch size of valve per psi of test pressure. And last, leakage class 6 means it refers to soft sheet or resilient sheet like PTFE. That means sheet having soft sheet like PTFE where there is no metal to metal contact. The sealing is by soft PTFE or soft sheeting. Sheet leakage rate will not exceed the amount indicated above. That means sheet leakage rate will be less than all the values indicated here when tested using air or nitrogen at 50 psi gauge pressure. Now, leakage class 1 refers to metal or soft sheeting, and leakage class 2 to 4 it refers to metal sheeting only, and leakage class 5 and 6 refers to soft sheeting. And all these leakage classes are applicable for gate, globe, check and ball valves, not butterfly valve. For butterfly valve, separate standard is there. And if we do not specify anything, then by default, this leakage class 4 will be applied. Because this leakage class 4 will almost match with the requirement of API 598. This leakage class 6 is the most stringent and leakage class 5 is also stringent. This table is the gist of all 6 valve leakage classes. As per API 598, there should not be any visible leakage from valve's body or from valve seat during testing, and these two tables indicate allowable leakage rate through the valve seat for all types of valves. As per API 598, for liquid test, 1 milliliter of leakage is considered as equivalent to 16 drops. During valve testing at valve manufacturer's works, we may get this type of minor leakage through valve seat and this type of water seepage through valve's body. This much of leakage is acceptable as per API 598 and the valve can be treated as per leakage class 4. So it is obvious that this much of leakage is not permitted in API 598 and the leakage rate is much more than leakage class 4. So this valve has to be replaced. But what is the reason of this type of leakage? This valve is not a local made valve. It is a Germany made stainless steel valve which has been delivered after testing. The reason of leakage is when this type of butt weld end valve is welded at site with pipeline, some precaution has to be taken. If we weld the valve with the pipeline keeping valve in closed condition, then due to welding heat, if soft seat is there, it will be damaged. Even if soft seat is not there, then also we can get leakage from the valve due to differential expansion of valve body and valve internals. So this type of butt weld end type valve should be welded with the pipeline after removing valve disc from valve's body bonnet joint. Another option is we can weld the valve with the pipeline, keeping the valve as full open and wrapping wet cloth over the valve body so that there will be minimum heat transfer from valve body to valve internals during welding. Now we have found this similar butt weld end stainless steel globe valve available with us and we want to use it as a replacement valve after leak testing. Usually valves are tested in this type of test bench at valve manufacturer's works. But since we do not have such test bench, for testing the valve we have welded two small stainless steel pipe pieces with this butt welded valve and two end plates at the end. Now from this nitrogen cylinder, pressurized nitrogen is being fed to the valve. Pressurized nitrogen is coming to the valve through this point and entire valve has been kept pressurized at 7 bar pressure at valve full open condition. Now the valve is being closed fully and pressurized nitrogen connection has been disconnected after closing this inlet valve. Now after opening other side valve, entrapped pressurized nitrogen has been vented fully and now leakage through the valve is being checked using soap water. Since soap bubbles are bursting after a long time, that means very minor leakage is there through the valve, and the valve can be used and can be treated as leakage class 4.